Hi guys, welcome back. Today we are going to take a look at I2C communication, which is basically TWI, which is a two-wire interface. And in this tutorial we are going to see how we can work with a sensor which is a MPU6050. The sensor gives the output based on the micro electromechanical structures inside. This sensor has a lot of features, so we are not going to discuss all of them. Let me be straight with some of the features. Let's see. This is the sensor that we will be using today, and it's called MPU6050. There is another sensor in the same series which is MPU6000, and that has a SPI communication as well. We will see the SPI communication in the future tutorials. Right now we are going to see how we can use it with the I2C, which is a TWI. And this sensor, as you can see, it has some pins, and we will discuss the pins. First of all, let's discuss its features. So the basic features of this sensor are it has a DMP, which is digital motion processor, and it can process the stuff. For example, it can process the accelerometer values, it can process the gyro values, and it also has extra pins which are XDA and XCL, which are for external sensor. We can also connect an external sensor with this. Right now we are going to see some of the pins, and the first pin on this sensor is VCC. Basically this pin is connected with 3.3 volts. Then we have a GND pin, which is connected with the ground. Then we have SCL pin, and then SDA pin. And as you remember from the previous tutorial, if you haven't watched my previous tutorial, just watch it now. And in the previous tutorial I have already discussed all the features of TWI communication, and in that tutorial we already discussed what this SCL means and what this SDA pin means. So we have to connect. Remember, we don't need to cross the wires. We will connect SCL with the SCL pin of the microcontroller and SDA pin with the SDA pin of microcontroller. Here we have a lot of flexibility. We can choose any pins in nRF devices, so we are going to just mention the pin numbers, and that's all. These are the 4 pins that we need right now. And there are some other pins as well, which are XDA and XCL. We can connect an external sensor with this. I will discuss it. First of all, let's see some other pins as well. We have here we have 2 more pins, which is interrupt and ADO. We are not concerned with those pins right now. So this is the basic sensor, and as you can see on the sensor we already have the resistors for the pull-up mechanism, so we don't need to connect any external resistors with 3.3 volts to make a pull-up circuit. Our sensor has some features, and let me introduce you if you are new to sensors, and especially the accelerometer and gyro. Let me explain a little difference between the gyro and accelerometer. Gyro is basically the positioning sensor. It tells the device's position. Like for example, if my device is in a straight position, or it's bended on some angle, specific angle, the values are going to reflect those angles, and in all the X, Y, and Z coordinates. So we can see in all the directions, like in which direction our device is bending. Basically it has an internal gyro, so we can read the internal registers of the gyro to get the gyro values. So with the help of gyro we can know the position of our device in specific angles or in degrees. The accelerometer is as the name suggests, this sensor is also inside it. So the accelerometer is basically giving the acceleration in terms of numerical values. For example, in this device I have x-axis, positive x-axis, and negative x-axis in these directions. Then if I move in this direction, the x-axis values are going to be increased because I'm moving in this direction and it's accelerating, and based on that acceleration I will get some values. So there is one thing missing in this sensor, which is the magnetometer. So the magnetometer is basically the third sensor which completes this series by helping us know the direction of our device. For example, my device is facing north, or my device is facing south, or any other directions. So the magnetometer can be connected with this. It has two other pins for that, which are SD and SCL, and we can connect that. We can use these two pins to connect to the magnetometer, and then we can receive all the values, and together once we receive all the values, we can read them via TWI communication, and we can store them in our nRF device. We can process these values, and we can also use its internal processor, which is the digital motion processor, which can process different gestures, and we can use it for many different purposes. For example, we can use it in remote controls or motion based controllers. We can use it in games, and also we can use it in camera and image stabilization. We have lots of applications for these sensors, and they are very useful. If I try to cover all of the sensors features, it's going to take a lot of time, so maybe I will create another tutorial based on this sensor. Right now, today, our main task is to connect with the sensor using I2C communication, and we are going to read the values from the sensor via I2C communication. And I think so for now this basic info is enough for us to start programming our device. So let's see. So I'm just gonna connect it back. So once I have connected the device, let's start programming our device. So okay guys, let's create a new project, but before creating a new project, I would like to let you know that I have already modified some of the code for the library, and we will be using this MPU6050 library. I have already modified it. We will discuss it once we have finished setting it up. So let's start creating a new project. Then we are going to put these files in the project, and we will see how we can reference these files, and then we are going to compile our code, and finally we are going to see the output of today's tutorial. So first of all, let's go and start from the basics. So we will go to this PC and then open this C directory. Here we have extracted over nRF SDK. So go into the examples and then go into the peripheral. Here we are going to copy TWI. We are just going to copy this, and then we are going to modify this. So go into my projects, paste it here, and open this. If you are using nRF52832, then open PCA10040. If you are using nRF52840, then open PCA10056. I'm using nRF52832, so I'm just gonna open this one, and then go into the blank, and open the SES, which is Sega Embedded Studio. Open this EM project file, and first of all, I'm gonna remove all of the extra stuff. So let's say I don't want this, and I'm just gonna remove everything. And let's say this is our basic program. I'm just gonna zoom in a little. First of all, we are going to add MPU6050 files. So right now, for that, just minimize this and go back to PCA10040, go to TWI. Here is the project files, and we are going to create a new folder here, and then we will put our library files in that. I've already created this folder with the library files. I'm just gonna paste it here, and here you can see we have MPU6050, and in MPU6050 we have a header file and a C file. Okay guys, so I'm just gonna minimize this, and then I will go to Sega Embedded Studio, and here in this project, right click here and make a new folder for the sensor, and let's name it as MPU6050. I have named it as MPU6050. You can name it anything you like. Okay, so I finished, and we have this folder here. But right now this folder does not have any files, and it's not referencing any files. For the files to be referenced, first of all we need to add the link to the files, otherwise it's not going to work. So right click here and go to options, and here you see a lot of options. We will just change the settings. There are two types of settings. One is the debug mode and the other is release mode. In the debug mode, basically we are checking and testing our work, and if it's okay, we can go in the release mode, compile the code, and then in the release mode the compiled code would be shorter. And right now we have to go into the common. Right now we are going to add these MPU6050 files, so go into the common settings. So now these are the common settings for both debug and release settings. So now it's we have set it to common, and now we will go to preprocessor, and here you can see user include directories. So if I click on this, you will see three dots here. Just click on these three dots, and in this set user include directory, you can see all of the files are using the / instead of backslash. So make sure when you add your new stuff, new library files or other stuff, make sure they are added using the / and not the backslash. So here I'm just gonna add the link for the file. So it's basically the folder. So I'm just gonna go here and I will copy this and I will paste it here, and then I'm gonna change it the backslash to /, and it's done. Once we have added this folder in the preprocessors, we can easily link the files, because the compiler now knows where are the files, so we can easily add these files in our project. I'm just telling the location of the files in this link only, and I will click on OK and OK, and we are set here. Now we need to add the files. So right click here and add existing file, and here we know that in the TWI scanner we have this file, and the file is in MPU6050, and it's going to be MPU6050 C file only. Okay, so open this, and now it's added. So if we double click on this file will be opened. It means it's working and it's added. If I try to right click here in the editor area, you can see if we go to include file, we can also open #include MPU6050.h. So let's open this file, and yeah, everything is okay, and we have opened these files, and we have this main code. And let's do one more thing here. I'm just gonna include MPU6050.h and save it, and let's try to build it. If it builds, it means everything is set and good to go. Yep, it built successfully, so it means the files the file it is referencing is already there. It's the folder is there, and it's been compiled, or all the stuff. So our stuff is ready, and now we need to program the code. But before that, let's see what's inside the library files, because I have already modified them, and I have already commented with all of the codes, so that once you are going to see the library files, you will understand a lot of stuff. And if you want to see more stuff, you can read the datasheet of MPU6050. In the future, I will create some tutorials on this sensor as well, because it has lots of features, and they need to be covered in multiple tutorials. So later on we will see, once we finish off the Bluetooth and all the stuff. So let's see in the MPU6050.h. Here we can see we have the device address, and as you remember from the previous tutorial, our devices have specific address, and here in this case it has D0. And if we right shift the D0, let's go and open the calculator. If I go into the programmer mode, open this hex, and let's type here D0 and double shift or right shift it by 1, and let's see what happens. It goes to 68, so it's telling that its address is 68 basically, and it's, if we shift it, right shift it, its address is 68. Okay, and the pins for SDA and SCL are 22 and 23. You can modify these pins, you can use any other pins you like. And if we go into the SDK config.h, let's see the configurations as well. So if we open CMSIS configuration, here in the nRF drivers, make sure TWI is enabled, and also TWI-M is enabled, because we will be using TWI-M because our device is acting as a master for the communication. So we will be using TWI-M. Make sure it's enabled, and in the legacy drivers, this is nRF5, and if we go in the legacy, and it's enabled, so the legacy driver should be enabled, otherwise the nRF5 drivers won't work. Right now we only need to communicate successfully with our sensor. Everything is good, everything is set and good to go. Just close this, and okay, we are here, and we have some registers which are internal registers of MPU6050, and these are the addresses of the registers. We can access these registers. We have already seen in the previous tutorial where I have introduced the I2C communication. We have seen how we can send the register address, then we can read or write data based on the read-write bit, and also the address of the registers. So if you haven't seen my previous tutorial, make sure you watch it and then come to this tutorial. And in all of this, the only thing that I have added is these two functions, the TWI master initialization and MPU6050 initialization. So let's go into the MPU6050.c file, and let's see what we have done here. So in MPU6050 we are going to include nRF driver, which is a TWI driver. Include file, we will include this .h file, and we will also include MPU6050.h, so we can use the register addresses. And here you can see we have initialized the TWI0, and then I have created a flag which is going to show if the transmission or receiving has been finished or not. And then we have this instant mTWI, which is basically the pointer to the instance ID, which is the TWI0. So similarly in all the communication that we have previously seen, it's similar. The TWI, we have a handler, and then we have initialization code. So first of all, let's see some initialization code. And this error code is basically a variable, and it is used to hold the error code. For example, if some error occurs during the initialization of this function, or during these functions something goes wrong, this error code is going to be passed to app error check. This app error check is going to give us the debug data in the output, so we can see where our code is malfunctioning, and then we can change our code, and we can directly set the stuff without even going into the proper debug mode, and we can do a lot of stuff with this. So in the initialization we have configuration, and we have already seen that we use our configuration, and in this configuration we can see we have TWI. These are basically the constants, and they are referencing to these constants. So TWI, SCLM, and SDA. So basically these are the pins. You can mention any pins you like, and the frequency for the communication is 400k. You can change it to 100k or 250k, whatever you like. The interrupt priority is high in this case, but if you are using Bluetooth, make sure you change the priority, or otherwise maybe you are going to see some faults. And a clear bus initialization is set to false, so we don't have any concern with this right now. And then we see we have initialized the TWI communication, and once it's initialized we will enable it. Once it's enabled, it's ready to communicate with the device. So this is basically the initialization. We have done the initialization, and there is an error. There is a event handler. If once the communication is finished, we are going to receive this event, and in this event we are just going to set the flag to let us know that the transfer or receiving procedures are completed. So let's see how MPU6050 is writing. We have some functions. In this function you can see it's taking some register address and then the value, which are in unsigned 8 integer values, and because its registers are 8 bits or 1 byte, so we have to write the stuff accordingly. And it's basically we are basically using a simple nRF drive TWI TX to transmit or to write into the register, and we are using this RX to receive from the register. And as you remember, we first of all we send the register address, so that's why we are writing into MPU6050 to set the register address, and then we will write it. So don't get yourself confused with this. And then we have verify product ID, as I might have mentioned in the previous tutorial, that every device which is communicating over I2C will have this who am I, or over SPI communication it will have this who am I, and we can use this register to see if we are communicating with the proper device or not. So if it's giving the proper value, this constant is basically here in the MPU6050.h, and you can see the who am I value, which is 0x68 here. So if you don't receive this 68, it means you are not connecting with MPU6050. And then we have MPU6050 initialization. In the initialization we are basically writing into some registers some initial values for reading and writing data, and some initialization stuff. So for that you have to read in detail how the MPU6050 works, but for the basics it's just setting up the power management. Then we are setting the sampling rate. For example, I need 5 samples in a second, I need 20 samples in a second, I need 100 samples in a second. We will set that using this register MPU sample rate, and these values are mentioned in the datasheet of the MPU6050, so you can check it out. And then we have some configurations. We can use different configuration to set our MPU6050 as per our application. And we have then we have MPU gyro configuration and accelerometer. We can use these configurations to set our gyro and accelerometer, so that we can read the values from gyro and accelerometer. And next we have functions for reading from gyro. The values in the MPU6050 registers are basically in 2's complement, and we have to convert them back to simple values so that we can use them. These values would be in positive and negative depending on the axis of rotation and all the stuff. So these values will represent the angles in degrees in the x, y and z axis to tell the device's position. And we also have an accelerometer read function, and this function just reads the internal registers from MPU6050, and then it converts these values back, and then we can get all these values. This library is doing all the stuff, so you don't need to worry about all the internal details. You just need to initialize it, and then we can read the accelerometer, and we can read the gyro values, and we can perform some stuff on it. So today I'm just going to write a simple program which is going to read the gyros and accelerometer values, and it's going to display them on the logger. So let's go into the main function. Here you can see here is our main function. Let's start writing the code. Okay, today we are going to write a simple program to read the stuff from MPU6050. So let's initialize the logger first of all. So remember, the values of accelerometer and gyro are in say integer 16-bit, and they can be positive and negative, so we are not using unsigned we will be using the signed integer. So for that, let's create an array in which we are going to save x, y, and z values of accelerometer and x, y, z angles of gyro. These values are basically in numbers, and we will convert these numbers into specific angles or degrees, and we can use them in different applications. Now we are just simply calling the TWI initialization function from this library. This initialization function is here. We are just simply calling this function to initialize our TWI, and we have already included this MPU6050.h, so we can see here these are the global functions. We can just call them. So I'm just going to initialize it. Let's give it some delay. And let's initialize our TWI, and until it's initialized we will wait. So we are just simply going to use a simple while loop to wait for the MPU6050 to initialize. And since MPU6050 after initialization, the MPU6050 returns a boolean value, and until it's false, it means it's not initialized yet, so we will just wait until then. And let's simply display some message. Okay, once the device is initialized, let's say we can give the user a message that our device is initialized successfully. So now we will give a message to the user that we are starting to read the values of accelerometer and gyro. So let's give some delay so that user can read this message. And now let's go into the while loop and read the values using the built-in function of the library, and we will read these values, and then we are going to display them on the log. We will save these values in this array, so we will use the same array, just we are changing its index. We are just changing the index of the array so that we can save the values in 0, 1, and 2 indexes respectively, and then we will see once it's successfully read, just display these values. Okay, and now we are just going to pass these values. So we are just passing these values so they can be displayed in a specific format like X, Y, and Z. And if the reading was unsuccessful, then let's give a message that the reading was unsuccessful. And now we are going to read the gyro values. The procedure is similar. We will just call the gyro function, which is in the library. It's here in the MPU6050.c, and you can see this value, this gyro reading here in this function. So basically it's going to read these values, so we are just going to call that function. Similar procedure, but this time we are going to use the gyro. And we are going to pass these values in this. If the reading was unsuccessful, we can just give an error message. And let's say after every 100 milliseconds I want to read these values, so it's done. And let's build it. Okay, it's built, and now we are going to test it, so make sure your device is connected. Okay guys, it's built. Make sure your device is connected with the USB, and also make sure the device, the serial port is also connected, so because we are going to see in the debug using the USB serial port. But before that, one thing we missed here is that we need to use nRF log flush, or we have to set the default mode, otherwise we will not receive the values. So I'm just going to go in the CMSIS configuration wizard here in the nRF log. If we go into the nRF log, and you can see here we have nRF log default enabled. Just disable this, save it, close it, and let's rebuild it, and then connect, erase all, and download it. Once it's downloaded, we will start receiving the values on the logger. So we have to connect our serial port, so make sure you have already connected the serial USB, and we will use the putty for this. And to check which serial port is connected, just open this PC, go into the properties here in the device manager. If you go here in the ports, you can see your USB serial is connected on the COM9. You can see whatever serial port is connected. I'm just going to open the putty terminal here in the serial. I will give the baud rate to be 115200, and it's connected with COM port 9. I'm just going to open this, and here you can see accelerometer and gyro values, but let's reset the device to see it from the start. So here it says it's initialized, and now it's reading these values, and after every 100 milliseconds it's reading these values. So if I try to tilt my device, let's see what's happening. So you can see the values are changing. I'm tilting my device, and acceleration values are changing drastically if I move my device faster around these axes. And you can see these values are changing, and based on these values we can create some gestures for our applications. We can use this for a lot of different application, in camera stabilization or some other remote control or some other stuff. So that's it for today, guys. I hope so you have learned something new today, and now I will add this code along with the library files and information So make sure you download this code and play with it, and make sure you get this MPU6050 to play with this and practice your coding skills with the I2C TWI communication. And if you are new to my channel, please be sure to subscribe to my channel, and if you haven't seen my previous tutorials, just watch them, and if you have any questions, you can ask me in the comments below. Thank you very much for watching. See you in the next video.